Today we're going to begin talking about systems of equations, and we're going to kind of circle back to how we began learning how to graph an equation. And what we're going to do first is we're going to check if this point 1, 2 is the solution to the graphed equation. We're going to do that graphically and algebraically. So to begin, I'm actually going to graph this equation y equals x plus 1. Now remember, this is already in slope-intercept form. And slope-intercept form is y equals mx plus b. And so our 1 is our b. And we actually have an invisible 1 in front of this x. And so our slope is also 1. And we begin with our b. So I'm going to place a point at 1. And if my slope is 1, I'm going to rise 1, run 1. Rise 1, run 1. And I keep doing that pattern, rise 1, run 1, because slope is rise over run. You can also go in the opposite direction, so down and to the left. And remember, more points, the better. All right. So now I am going to check to see if this point 1, 2 is on the line. So let me find 1, 2, and it is right here, so it is on the line. So yes, it is a solution, but we're also going to check algebraically, and we already talked about this the other day. We're going to actually plug this into the equation y equals x plus 1. Well, this is my x, and this is my y. So I'm going to replace my x with 1. And add 1 and replace my y with 2. Well, 1 plus 1 is 2. Does 2 equal 2? Yes, it does. It is a solution. Okay, we're going to follow that same process and do that again. So is the point 4, 3 a solution to the graph line y equals negative x minus 1? So again, my y-intercept is negative 1, so I'm going to begin with my b, place a point, and then my slope is negative 2, so I'm going to go down 2 over 1, down 2 over 1. Okay, now that I have my graph line, I'm going to check for 4, 3. I'm going to look and place a point at 4, 3, and here's 4, 3. No, this is not a solution because this point does not fall on the line. I still need to check my answer by plugging in my x and y values. So I have y equals negative 2x minus 1. X is going in place, well, 4 is going in place of x. And we should get an answer of 3 because that's in place of y. So if I do negative 2 times 4, that's negative 8 minus 1. And negative 8 minus 1 is negative 9. So this is not a true statement. It is not a solution. Okay, so moving on to systems of equations. A system of equations is a set of one or more equations. And this year you only have to solve them graphically. So going back to the steps for solving a system of equations. Step 1, make sure that the equations are in slope-intercept form, which is y equals mx plus b. Then you are going to graph the equation. So remember to begin with your b. Then you're going to, step 3 is locate the point where the equations intersect. Okay, so now we're going to look at some examples of how to find solutions to systems of equations. So really, a solution is where the system or the two equations intersect. So we are looking for where the two lines intersect. And if you look at this graph, we find one point right here, and that is at the coordinates 3, 5. So that is the solution to both of these equations, 3, 5. And what I can do is I can write my equation of each of these lines and plug that in, and it will make a true statement. So the equation of this line right here is y equals x plus 2. And the equation of this line right here looks like it is, my slope is negative 1/3. So it's y equals negative 1/3 x plus 6. So what I can do is plug these coordinates into those equations to see if they are true. So if I plug in 3 for x and I into this equation, x plus 2, and 5 for y, does 3 plus 2 equal 5? Yes, it does. So this is a true statement. It is a solution. Now to plug in my next equation, negative 1/3 x, which is 3, plus 6, it should equal 5. Well, negative 1/3 times 3 is negative 1 plus 6. Well, negative 1 plus 6 does equal 5. All right, moving on to the next example. This time we're just going to identify. So identify the solution with this system of equations. I'm going to zoom in. At what point do my two lines intersect? Well, if we look here, we're at 2, negative 5. So my coordinates are 2, negative 5. That is the solution to that system of equations. Okay, for the last two examples, they are going to be a little bit longer because we actually have to graph our systems first. So remember, we are using y equals mx plus b, and we begin with our b. Okay, and so this equation, actually, the first one that we're going to do should be plus 1. And so our b is positive 1. We're going to start there and place a point at positive 1. And then we're going to go down to the right 1, and we're going to follow that pattern down 2 over 1 and into the other direction until we have a line. We're going to follow that same pattern for our next equation, y equals 2x minus 3, and we're going to begin with our b, which is negative 3. And we're going to go up 2 over 1, up 2 over 1, and continue that pattern until we have a line graphed. And then if you notice, look at our two lines intersect at 1, negative 1. So that is the solution to this system right here, is 1, negative 1. Okay, for our last one, we're going to do the same thing. We are going to graph the two systems, or the two equations, and then find the solution to the system. So we're going to begin with y equals 1/2 x plus 1. So our b is 1. And we're going to go up, rise 1, run 2, rise 1, run 2, and continue that pattern until we have a line. And then we're going to repeat that, and we are going to graph y equals x. And since there is no b, we begin in the center, and our slope is 1. All right, and this is why I was saying precision is important in using a ruler, because if we look at this graph, it looks like they intersect at multiple spots, but really they only intersect at this one point right here, which is 2, 2. So the solution of this system is 2, 2.